Hi, everyone. It's very nice to meet you all. My name is Nadia. I'm the communications lead at Hero.io, and I'm very thrilled to welcome you to the Cambridge Research AI for Web3 event. Our speakers will share the latest advancements, exploring how companies founded by Cambridge University alumni are using AI to tackle challenges in Web3. This event is organized by us, Hero.io. We are a Web3 super app that integrates a private browser, AI search engine, wallet, merchant services, and much more. And we are hosting this event with wonderful partners. The first partner is Apta AI, an AI company founded by Cambridge University PhDs. And they're using logic-based LLMs and combining with bespoke AI models to deliver precise context-aware insights. And our second partner is the Innovation Game, a unique protocol that incentivizes algorithmic innovation. So please welcome the first speaker, Dr. Shriram Chabra, CEO and co-founder of Apta AI, powering Hero AI search.
Perfect. Thank you so much. So yeah, thank you so much for joining us all on an early morning in Bangkok. I don't know if any of you are suffering from jet lag, but really appreciate you all being here. So what am I here to talk about today? So I'm the CEO of Apta, as Nadia mentioned. And what we are is we're a spin out from the University of Cambridge that's developing the next generation of conversational AI. So conversational AI that doesn't just output an answer, but actually reasons when it does so, and can actually interface and action agents. In so doing, it's capable of delivering more robust and accurate and deeper insights, and also enables us to execute downstream workflows because of this. Now, we're applying our technology to solve a problem in Web3, and that problem is the idea of information disaggregation. Right now, crypto is in a state of chaos, information absolutely everywhere, and this also applies to the emerging AI agent economy that's booming right now. So we've collaborated with Hero, as Nadia mentioned, an ecosystem of Web3 first products. And together, we're building what we hope will become the new Perplexity search, the new Google of Web3, the single landing point where users will enter the Web3 world, type in their intent through chat, and be navigated to the correct location. OK, so just before I kind of start, who is here for more of the kind of hardcore AI side of things? Can I get a show of hands? OK, so a few of you. And who's here more for the applications of AI in Web3? OK, so a few more. Great. And I guess those who didn't put your hands up, you're here for the free food, I'm guessing, right? OK. I think today's talk will hopefully cater to both audiences. We'll definitely try and also focus a lot on the applications of AI to Web3. So let me kind of go into a little bit more detail what I want to cover today. So first, I want to start from the AI side. I want to tell you about conversational AI, and it's all been around models called large language models. So I'll explain to you where they started in 2017 and where they've got to today. I'm then going to explain to you why LLMs alone are not the be-all and end-all, and why the next big thing is agentic flow. I'm then going to explain, thirdly, why agentic flow in its current capacity, when it's used by some of the biggest models in the world like ChatGPT, is not suitable for specialized purposes, and why Apta is solving that problem. And finally, I'm going to talk about the application of agentic flow as built by Apta in the context of Web3 through Hero. Great. So let's start with the first of those points. What are LLMs? How have they progressed? Now, just to give you a little bit of background to the team, the whole talk today is about Cambridge AI and Web3. So the team at Apta is exactly that. Myself and my three co-founders, we're all PhDs from the university. In a very British fashion, I'm not going to talk about myself. I'm going to talk about my co-founders first. The three of them all have been doing their PhDs in the Machine Intelligence Lab at the University of Cambridge, specifically within the speech group. They've been at the forefront of NLP research for 5 years. And just to give you some context, LLMs themselves are only really 7 years old. So they might only be 26 or 27, but really they are veterans in the LLM field. And I think we can start to see some gray hairs, especially with Vatsal and Vyas, to kind of show this. So they've collectively published over 30 papers in LLMs and NLP, and have amassed over 1,000 citations. So that's the team at Apta. In terms of my background, I did my PhD in computational biology, applying AI and machine learning to the biotech landscape. I then joined McKinsey, where I was working with Quantum Black, and that's when I really started focusing on LLMs, especially in an enterprise setting. Okay, so that's the team at Apta, and also a lot of what I want to talk about today and how we've ended up with focusing on agentic flow comes from our experience after the academics, is actually when we were consultants. We started a consultancy called Cambridge AI Studios, and that worked with a range of players in the AI space. So we worked with some of the biggest AI companies. We worked with a company called Sambanova. I'm sure you're going to see these guys in the next few years. They're an emerging competitor to NVIDIA. We also work with some of the largest AI institutions that are looking to adopt AI, not develop it. So the NHS in England and the Saudi Council of Health Insurance. And then from the other side of the table, we worked with some leading AI investors. So specifically, we did due diligence for a fund called Dawn Capital, a fund that has recently raised $700 million just for generative AI. And essentially, through these experiences, we noticed a big flaw with conversational AI. And that's what I want to quickly explain to you now. So LLMs, like I said, they came about in 2017 and 2018 when a new architecture called the transformer architecture came about. So essentially what the transformer architecture enabled us to do is to train models on more data than we could ever do before. And what the first researchers did is they trained these models on sentences from Wikipedia. And this is what the first model came about, which was in 2018, the first LLM. It was called BERT. It was made by Google. And essentially, what these initial LLMs did, and what I really want you to take away from this, is these LLMs were trained to predict missing words. So we gave them lots and lots of sentences and masked individual words in those sentences. And then we trained the LLM to fill in the missing word. So basically, at the end of this whole process, what emerged were LLMs that have a very good grasp of English language. Essentially, they're very, very good at completing your sentences. So that was what the first LLMs were, but they didn't really take off. I don't think many of us in this room perhaps used an LLM before ChatGPT in 2022, but they've been around for many years. And what changed that was a company called OpenAI, which everyone knows now. And what they did is they took these LLMs, which have a very good grasp of the English language, and actually made them do useful things downstream of that. So they took these models and asked them to do tasks. Translate this, or summarize this text, write a poem, whatever task that you can see right now with LLMs, they were trained to do that, and it's called instruction fine-tuning. And at the end of this, what emerged were LLMs that not only had a very good grasp of the English language, but they could actually do useful tasks with that ability. And that's the LLMs that we know today, and more companies are releasing more foundational models every day. You know, we have Claude, Mistral, Gemini. Okay, so LLMs are great. They've revolutionized the way we interact with technology. What's the problem? Well, let me kind of go into those problems now. I think they're essentially twofold. The first big problem with large language models is that these models aren't designed to natively handle data types beyond text, right? Think of all the other forms of data in the world, very important in every use case, especially crypto, right? Things like structured data. Imagine how much data is stored in large tables, or, for example, the blockchain, a structured form of data. Then you also have numerical data, which these models aren't designed to handle from the outset. You have charts and diagrams, which are effectively text, but organized spatially. And then you also have multimodal data. What I mean by that are images and videos. LLMs themselves aren't designed to handle this information. They're just designed to handle text. Now, there is a lot of research going on to essentially expand the capabilities of LLMs to handle these data types. But the second bigger problem is the fact that LLMs don't reason when they produce an output. And I'll give you an example to show this. So what that means is because they can't reason, they can't really do complex steps that require multiple areas of reasoning. So let's just go through an example. So here's a question: what is the weather today? On the surface, this question seems very trivial, right? But even the most trivial of questions like this actually requires reasoning. So when you ask this question to an LLM out of the box, the way it produces an output is by predicting which word will follow next. So it looks at all the words in the vocabulary, and it looks at words like microphone, carpet, stand. These words are very unlikely to follow that prompt. So it's not going to produce them with a high probability. But words like rainy, cloudy, sunny, they have a much higher chance, right? These are words we commonly see following this prompt. And it's just going to predict one of those outputs by chance, right? There's no really reasoning there. There's no logic. That's not how you're meant to answer this question. So this is a very big problem with LLMs. Number one, they don't reason. But actually, they also don't do anything. They just produce a text output. You can't start actioning with LLMs alone. So the field has kind of understood that this is a big problem. And this is not new, right? One of the earliest pioneers of LLMs, Jan LeCun from Meta, he said this problem right from the outset. And the field has introduced a kind of new paradigm, an extension of large language models. And this is called agentic flow, and this is exactly what Apta builds. So basically, in agentic flow, we try and use a technology exactly what it's used for. That's what the meaning of Apta is. Apta is a Latin word for correct or suitable. Right now, everyone, or a lot of people, are trying to use LLMs to do absolutely everything. We're essentially trying to screw a nail with a hammer. It's just the wrong technology. So in agentic flow, what we do is we try and use LLMs for exactly what they're good at, and that's their language ability. We use them just as communicators in a system. So the LLM is essentially your ears at the start of a process, listening to the intent of your question, and the mouth at the end of the process, speaking the answer out through language. And that's it. We're not using the LLM to do any of the complex reasoning, because it can't reason. It's just spitting out words. So what we do in agentic flow is we pass the same question in, what is the weather today? We pass that to the LLM, which uses its language ability to understand the intent of the question, and that's it now. The LLM is not doing any more. The next step is called task decomposition. We try and use reasoning to break that intent down into logical steps. So the first of those is I need to find out my user's location, and then the second of those is I need to find what the live weather is in that location. And then what we do is we orchestrate. So we then pass on these individual tasks to individual agents that are designed to do that task. So the first task was to find the user's location. We'll have an agent 1, which is specifically designed to identify your location. This might be a software engineering package. This might be a machine learning model or a deep learning model. It doesn't matter. What matters is this model is deterministic. It's not probabilistic. Deterministic means there's one exact answer to each input. And also it's designed specifically for that task and data type only. This could be numerical data, unstructured data, it doesn't matter. So the first agent is identifying your location, perhaps using your IP address. It works out that you're perhaps in Bangkok or Dubai. And then it passes that information on to a second agent. And that agent is a live weather agent. This has basically a database of live weather, and we then cross-reference what is the weather in Bangkok or Dubai. Now, the second agent produces an answer. It's a correct answer, but it's not necessarily in the most intuitive format. This is in a dictionary format. So in the final step, what we do is we pass this back to the large language model, which then speaks the answer out in a nice conversational response. And that's essentially agentic flow in a nutshell. So I mentioned at the start of the talk that companies like OpenAI are aware of this, and they actually started to excitingly integrate agentic flow into their own product through the model GPT-4o. So I want to quickly talk about what they're doing and why that application of agentic flow is not going to be useful in specific domains like crypto. So OpenAI, through GPT-4o, offers what I call a range of generalist agentic functions. So the first of these that probably we use the most is called the web search agent. I'm not sure how many of you remember even recently with ChatGPT, that you would ask a question, for example, who is the president of the US? And it would always give you a warning, I'm only trained up until November 2022, right? That was when the LLM was doing the whole thinking and reasoning itself. So what OpenAI did is they realized that that's not really useful for answering up-to-date, changing, information about changing information. So they integrated the web search agent. So what you do this time is the LLM understands your intent, it realizes this requires live information, and it then triggers a web search. And that web search agent goes ahead and answers your question. There's 3 other agents they offer. The second is a Python code agent. It enables the LLM to actually do maths, not just regenerate maths it's seen online somewhere. it can also upload a file, so you can read a file. And finally, it can also analyze images. So then, like I said, addressing a problem of not being able to handle videos and images. And like I said, these models and these agents are great. They're very generalist. And what that means is they cater to a broad set of use cases. But that kind of broad approach also has the problem that you can't really get much deeper insights into a particular niche. So I think the best way to demonstrate that is to give you a pretty concrete example. So let's imagine that I am an equities trader. I'm trying to tell my traders in my bank what stocks they should be investing in. So I want to ask a conversational AI, what are the attributes of US stocks or, for example, cryptos that perform best in 2024, in August? Now, the first problem with generalist models is that these agents are too broad. You can't answer this very, very specialized question in a particular domain with a web search agent, let alone Python, code generation, image upload, file upload, right? It's just too specialized of a task. What we actually need for this type of question is we need some form of explainable machine learning model, right? Something like a decision tree which can look at all those attributes and identify which ones are associated with the best performing stocks. So that's the first problem with these generalist foundational models. They just don't have access to the specialized agents that we need for our use cases. But then let's imagine somehow that ChatGPT does have access to every specialized niche agent in the world. The second problem is it doesn't have access to the specific data streams we need to power these agents. So for this agent, this explainable machine learning model, this decision tree, I need time series information of all cryptos or US stocks from August 2024, and I need all their metadata. You know, what type of company are there, what are their financials, et cetera, et cetera. And that's the second problem. But finally, let's imagine a utopia. Somehow, OpenAI has every agent in the world and all the data in the world. The third big problem is latency. Agentic architectures are very, very slow, right? And that's because they're reactive. You type a question in, and the computation starts. And often the latency in these agentic architectures can be quite slow that it kind of detracts from the user experience. So those are the problems with agentic flow. Let me tell you now what we're doing at Apta. So the way that we solve this is by being completely contrarian. We're not trying to create a foundational model that caters to every single use case. Rather, we're building bottom up. We focus on specific verticals, one at a time, for example, crypto or healthcare. And then what we do is we build or we incorporate domain specialized agents, which are powered by tailored data streams for that task. We then orchestrate these agents with our agentic flow architecture. What I mean there is we have that step which can break down intent into tasks, and then we're very good at connecting those tasks up to the right agents in the right order, right? When you're asking someone's weather, you can't read the database first, the weather database first, before finding the user's location. You have to do it the right way around. And then the third thing that we really excel in is how we can make agentic architectures very, very quick. We have very, very low latency. And the way we do that is because we're very focused on one specific vertical, one specific domain. We understand what the use cases are in that domain. And we therefore pre-compute complex steps in advance before the users even ask the question. We're preemptive. So if I give you an example, imagine a user asks, when Bitcoin sentiment is positive for 3 days in a row, send me a notification or buy me some Bitcoin, right? A conventional agentic flow, let's imagine the utopia where ChatGPT has that agent, it will just start that process when you type the question in. But we understand that people want Bitcoin sentiment or sentiment in general about cryptos. So we've already pre-collected all the media sources, we've already labeled those with Bitcoin, and we've also calculated the sentiment in advance. So when a user asks that question, we can very quickly on the fly deliver the answer with very low latency. So I've gone a bit more kind of from the concepts and the technology. I now want to talk about the application of this AI to the Web3 space. And I think a lot of you are here for that today. So essentially, we are powering Hero's AI search with our agentic flow. And our vision, like I said, in the long term, is to become the new way of searching through Web3, through chat. Many of you might have used Perplexity. It's going to change the way Google works. And we essentially want to become the conversational Google of Web3. But in the short term, what our immediate goal is to become a co-pilot that can provide easy information access about crypto tokens, solving the problem of information asymmetry and information chaos. And secondly, we want to democratize and make analytics on tokens available to the mass market. Right now, research and analytics is often ring-fenced to those who have lots of analysts, the high net worth individuals, or those who can afford multiple expensive subscriptions. We want to bring this all together in one place. And this is essentially our architecture. So I'll give you a quick whistle-top tour of some of the features that we have with Hero. So we're not just targeting advanced users, we're targeting everyone in the crypto space, especially the new incumbents who are entering Web3. So the first agent that we have is called the fundamental knowledge agent up here. Essentially what this can do is answer any question about crypto, any definition like a DAO, or questions like how can I buy something with MetaMask, or how can I make a cross-chain swap. The second, which comes part and parcel with this, is the live market and the market analytics expert. This enables you to search live market information and do complex filtering. And I'll give you an example of this next. A lot of our users, for example, use this to find tokens that meet their particular investment theses. A user recently told me something that kind of surprised me. He asked a question. He's a swing trader, and he basically asked our system a question: which crypto tokens have dropped by 90% and returned back to normal the most times? A very kind of interesting question. I never kind of thought of it before. And essentially, he wanted to find tokens that do this the most. And interestingly, it's a token called White Yorkshire. It's done that 48 times over the last 3 months. So he could find that token specifically by just asking our system. The third that we have is investment signals, basically quantitative indicators that can give you a little bit more insight into the medium, short, and long-term quantitative metrics of whether the token might go up or down. Live news, up to date every single day, and the blockchain explorer. Essentially, type your wallet in or anyone's wallet, search the block, all through chat. I'm going to give you a quick demo of this in action. And by the way, I'm going to be outside as well in the networking area, and I'll be happy to kind of show this in action. So it's a bit small, but essentially what we're doing here is a user, they're basically, they like to buy the dip, right? So they're asking which gaming coins have a small to medium market cap, 2 to 100 million, have hit their all-time low in the last 2 months, and haven't increased more than 20% since, right? They're trying to buy the dip of gaming coins. And we can see that the system rapidly, with very, very low latency, is producing all the tokens that meet that criteria. You can dig deeper and find lots of background information about these tokens, or ask them in chat. And now they're asking a follow-on. They want to time their entry into the market, so they're asking what the quantitative or technical indicators are suggesting about this token. And we can see we've already understood that users asked this question. We've pre-computed this, a lot of these indicators for these tokens. And basically, when the user asks this, with very low latency, we simply aggregate all this information together and show them the overall outlook. You can see it's completely multimodal as well. So that's kind of an example of what we have now in the Web3 space. And now I want to talk to you about one exciting feature that we're looking to bring in next. And this is called our influencer validator. So we know that there's a lot of KOLs in crypto, and KOLs, and especially their calls, drive the market. So we want to kind of shake up the space, right? It's not fair that a group of KOLs have a lot of power in this space. We want to make them accountable. So now you can ask, this KOL has told me to buy a particular token. What's their track record? It will show you their track record across time. How often were they right? But also a lot more granularity as well. You probably tell you also how long after they make a call does the token go up before crashing. So therefore, you can make much more informed and well-led and well-thought-out investment decisions. So that's the product. If you're interested in getting early access to the tool, please scan the QR code here, and you can join our already group of beta testers. So yeah, I'll keep that on the screen for a few seconds, and then I'll move on.
Thank you, Sharon.
Sorry, just got a couple more slides. Perfect. Great. Cool. Okay, so the final thing I want to kind of talk about is the idea of a future problem that's coming out right now. So when we talk about AI and Web3, the biggest topic is the idea of AI agents. AI agents are essentially these autonomous models that right now are very focused on executing TradFi trades. So these agents kind of suffer from the same problem as the rest of information in crypto. They're siloed. They're completely all over the place. It's very hard to meaningfully connect them through one interface. So going forward, we don't want to just keep building out our own agents that are focused on information access and research. We want to start integrating a whole economy of builders who are building agents that execute, right? And essentially, what we want to offer is the orchestration layer, the ability to take a user's intent through chat, massively opening up the playing field. Now you don't need to be a very sophisticated crypto trader. You simply just need to message your intent in through chat. And then Hero's system will then lead you to the most appropriate agent, either on-chain, that does the particular task that you want it to do, or off-chain, that could be providing you information and research. So yeah, on that note, very happy to take any questions. Thank you so much for listening. That's my Telegram over there. If you'd like to connect, I'd love to speak to as many of you as I can. And yeah, if you are someone who can see the value of the technology, would be interested in helping us build out certain features, please let me know. Also, if you're an AI engineer or a builder in the space looking to work with a world-leading team, we're also looking to bring on more engineers in Cambridge as well. So yeah, thank you so much for listening, and happy to take any questions or move on.
Hi, good morning. This is Akrish. I'm from Dubai. We are also building AI wrapper layer. We have deployed OpenAI with the LangChain and coupled it with Gemini and Copilot. So I have a very specific question. Do you have a playbook of prompts, or when somebody gives a prompt on your interface, it is coded in a natural language, or there's a playbook of certain prompts we have to give in order to get the right kind of action? Just for example, if I want to buy 100 BTC from my wallet, do I prompt it into a certain manner, or there's a playbook from where I need to select?
Yeah, great question. So he's asking a question about LangChain. So essentially, LangChain right now is a zero-code architecture to build agentic flow solutions. And a lot of people building agentic flow use that. So the way LangChain works is you have agents, and you basically give a description of what that agent does, right? And therefore, the LangChain is very, tries to link a particular intent to that agent. We kind of see a big limitation with that kind of way of prompting agentic architecture. So we use a completely different approach. What we do is for every single agent, we explore the whole scope of potential use cases, and we use an embedding-based approach, right? Very similar to what's used in RAG. So I'm getting very technical, but hopefully that answers your question. So essentially, you have a feature space of intent, right? These are words which have semantics, and essentially the embedding space is trying to capture meaning. And essentially, in this high-dimensional space, we create clusters of the types of queries or the types of things you can do with particular agents. And we use an embedding approach to do the routing. So we're not using simple language and simple descriptions to then prompt. So that way you get much more higher fidelity routing. It's a big problem with LangChain right now, right? Without being very templated, often routing layer can be quite bad. So this kind of form of semantic routing that we do it enables you to kind of deal with the much larger permutations of intent you get through natural language. So hopefully that answers your question. Yeah.
Hi. Yeah, I want to ask, if we are building our own kind of user-facing, LLM models, do you actually open direct access to your agents itself, not with the reasoning parts, so that we can also integrate, yeah.
Yeah. So there's been a number of people we've spoken to that are particularly interested in one of our agents individually. So, for example, we were speaking to a large exchange who really liked our news feed, right? Because we produce daily news summaries that are weighted by recency. A lot of the problems with Google search, the perplexity is they will tell you information from weeks ago, right? We don't want that. And also, we have a very good sentiment score as well for news. So yeah, we are looking at also individually providing our agents as API endpoints as well.
Okay. I'll come to you first.
You have a question? Yeah, also here.
Hi, I was just had a question, like what other domains is Apta working on besides crypto?
Sure.
And where is the interest generally right now?
Great. So yeah, Apta is a completely industry agnostic technology. Right now, we're heavily focused on the financial space. So alongside crypto as well, we're also working in traditional finance and equities. And kind of going forward, this is kind of a very good mirror of how various industries tend to adopt new technology, right? So often industries like finance are often one of the first to incorporate these technologies because they have a lot of capital to invest in these things, and also if it can even offer a small increase in alpha or a small reduction or in kind of workforce or productivity, it's used first. Hopefully, like my kind of long-term vision is, we already had conversation about this, is integrating this not directly into healthcare, but healthcare insurance. Essentially, what Apta really offers is, because it's capable of doing multi-step reasoning, it can automate very complex workflows that are done in lots of businesses. So, insurance, especially healthcare insurance, is one of those industries where you have a whole range of very manual, complex steps that require following various rules. So, a customer picks up the phone, they've asked for a particular set of physiotherapy appointments because they've got a pain in their leg. The agent that picks up that phone needs to go through processing and say, firstly, is this member covered or not? And secondly, do their symptoms match with what's covered under their insurance package? That's kind of an agent itself. And then kind of downstream of this, they have completely separate models which try and forecast the spend of users. So it's a very, very interesting industry that we're also having conversations with one of the biggest insuring providers in the UK as well. So we're very, very open for people as well to come up to us if they can see a very complex and intensively manual set of workflows in businesses, and hopefully we can come in and help increase the productivity or automate the workflows in that space.
I have a question. So I see in our graph you show on a presentation before, there's a step called deconstructing the prompt and try routing, right?
Yeah.
Are you using a specific statistical model or a rule-based model to do this decomposition task, or I mean, like, how do you construct the prompt to put to the LLM to do the decomposing task, or you use another specific model on your side to do that?
It literally, so the way that we do it is the way I described before. We basically create a feature space, an embedding space, which captures semantics. For each individual agent, in natural language, we're able to incorporate the whole kind of set of prompts that kind of follow that space. So if you've got a live market expert, we have in embedding space basically the whole set of types of questions that can answer, right? And then when a user asks that question, we map that down into the embedding spaces. So if you ask a question like, when the price of Bitcoin is over 63,000 and the new sentiment is positive, sending an alert. What would happen in our embedding space is that semantics will be mapped to two clusters, right? One cluster will be the live market expert, which has that set of functionalities, and the other will be the news expert. And therefore, we use that heat map and the nearest neighbors in that embedding space to trigger the right agent. So we do routing differently.
Because you're talking about large language model here, I assume that you're gonna use some OpenAI engine at the behind, right?
So yeah.
But how do you transfer the embedding vector to the system? Or you have to convert it to some human readable text to put to the system?
So firstly, the LLM that we use right now, LLM is kind of like the smallest piece of the puzzle. So right now we're using Llama 3.1 for this particular task. And then, yes, we essentially vectorize that natural intent input and put that into the embedding space. So this is very much using the similar approach to RAG. So that's how we get from that natural language intent and then vectorize that and put that into embedding space. That's how you produce that conduit between natural language and the feature space.
I see. So for the way you vectorize this, you said that you still need to use a specific model, right? So it should be domain specific model, right? Or it's not like using the same model for all domain, right?
So yeah, interestingly, so the question is, when it comes to actually intent understanding, the intent, which is basically what the language is trying to say, LLMs off the shelf have very good capability of that. Actually, if you look at ChatGPT off the shelf, it has pretty good understanding of even crypto terms. So all we need to do is actually, the smart reasoning step comes in that embedding space. You don't need the LLM to do that step, right? So it's all about the LLM taking the intent and just essentially creating a vector in that embedding space. And then the embedding space is the part which does the task decomposition and prompt routing.
Okay.
So we're kind of moving away from the LLM. Happy to catch up afterwards, but another way of doing this is through chain of thought LLMs as well. That's another way of kind of skipping the step altogether.
Okay. Thank you.
Sorry, I'm going to ask my last question. So, as you mentioned that you're focused on the fintech and a crypto domain. So, we are trying to build AI layer, which does, our focus is text. So, we are text to transact, voice to transact, and transaction via AI agent. We are deploying certain tech around that. So, I want to know specifically, do you have an agentic flow where you give prompt and conduct buy 100 USDT via Wallet Connect, and we do certain wallet integration like Web3 Authenticator or Rainbow Kit. It chooses all available wallet and conduct transaction right via prompt, or if you have already connected your wallet, you have certain USDT in your wallet, and you want to stake it, it gives you a possible liquidity pool and find you the best safe buy.
Great question. So right now, the agents that we've built in-house are focused on 2 layers before. So our kind of hypothesis is that people want to walk before they can run. With the new technology out there, especially with AI, even for advanced traders, I think they want to see that the AI is able to provide basic information, basic analytics before just completely executing the trade out of the box, right? So we built those 2 layers first, and right now we haven't built any execution agent right now that's available in the beta version. But we are essentially looking to connect with solvers who can then essentially execute trades. So that's kind of in our product roadmap right now, but we're focusing on the foundational layers that we think are important before that. When you type a question in, it should be able to answer questions and give you research before just taking in and doing a trade for me. So yeah, we're gonna get there, and the way we're gonna get there is hopefully by either doing it in-house, but also collaborating with people who are building these execution agents on the chain.
Yeah. So you mentioned like tailored data stream. So my question was like, from where are you taking the data, and which format? Since LLMs are better suited with the text data. Yeah. And my question, for example, if I say which coin went up for the past 24 hours, which chain would you get the data from? So how can I make sure that you went to all chains or which specific chain?
Yeah, great question. So one of the privileges of working with Hero is they have a whole data team, the Hero data team, right? Essentially, their role is to produce these data streams for us. So when it comes to market information, they essentially aggregating a range of live market sources. So this is looking at tools like CoinGecko, CoinMarketCap, aggregating a whole view of the market across various chains, and also integrating smaller tokens that are much harder to find on these kind of mainstream platforms as well. So essentially, for the market side, we aggregate a lot of information together. And then the Heroes team for other layers actually goes out and generates a lot of those data streams themselves. So they're doing a lot of work on curated token unlock events for tokens, a kind of data stream which is conventionally very, very bad from the mainstream providers, as well as also finding personnel behind projects, right? So often people want to know if people from one project have had a bad or a good track record in the past. Hero has gone out actually and produced that list themselves. So yes, for a lot of the mainstream data, we don't want to reinvent the wheel. We aggregate lots of sources together, and then for other data forms which are not necessarily very well represented, we go out and collect them themselves. And when I mean we, I talk about Hero's data team.
Do we have any more questions for Sharon?
If you do, happy to take any more questions outside. I think we'll also let the next speaker have a chance as well.
Okay, so thank you, Sharon, for deep insights and presenting Apta's approach for Hero AI search. We will meet Sharon a bit later. And now let me introduce our second speaker, Kilian. Kilian is a senior researcher at the Innovation Game. So yeah, let's welcome Kilian.
Coming on. 1 second. Yeah, it's not coming on. Let me just. Alright, so presentation is here. Huh? Yes. You have another one? I try mine as well. 1 second. Yeah. Thank you for everyone showing up and waiting for these small technical difficulties. My name is Killian and I'm part of the innovation game, which was founded by John Fletcher. He couldn't make it, unfortunately, so I had to jump in last minute. We are also both PhDs. Well, I'm not a PhD yet. It will be done in a month. And John is a PhD in applied mathematics. I do a PhD in astrophysics and machine learning. And we are both doing blockchain, more or less. So I'm here to talk to you about what is the innovation game. With the theme, we are incentivizing decentralized innovation in the age of AI. So this is our mission statement as already announced by the kind introduction from the host. And what does that even mean, like incentivizing algorithmic innovation? Well, for instance, if you look at the whole AI sector, recent progress has been mainly hardware-driven. So everyone knows NVIDIA. They're creating more and more powerful GPUs to train these more and more larger models with billions of parameters. And the progress that was made in the last, let's say, 10 years in this field was mainly due to this hardware-driven approach of incremental successions. And as you see here on this curve, the blue curve is basically what we are reaching with CPU, optimizing CPUs. And the green curve is basically the performance boost when we optimize GPUs, right? So actually, people might know more the term Moore's law for computing power. And actually, people are talking about Huang's law now, which is the green curve. Huang is the last name of the founder of NVIDIA, because as you see, the blue curve is kind of saturating. The Moore's law is not following a linear relationship anymore. but GPU is steadily increasing with a much deeper, much steeper curve, right? So we're actually following Huang's law instead. So now we have this problem that we are basically only reaching progress in hardware-driven approaches, which is not very efficient. If we think of more about what the AI field in general did in the literature, we can identify various algorithms that are now used in state-of-the-art training and had significant impact on the whole research field. One of the first ones is the Adam optimizer. I'm not sure how many are familiar with that, but that's basically the standard optimization algorithm that is used to train one single data instance for the machine learning model. So it was published 10 years ago in 2014, and it is one of the most cited papers in the whole scientific literature. So just to give you a number, 190,000 people have cited this paper. So it is a very influential algorithm, right? And then the second revolution happened already 2 years later, in 2016, when the attention mechanism was introduced to revolutionize sequential data processing tasks. And out of the attention mechanism, we created the transformer architecture, right? And apart from that, there's nothing really happening afterwards. So our question is okay, instead of optimizing on the hardware, we can achieve significant progress just by optimizing or inventing new algorithms. So our question is, what is the new Adam for the future, or the next generation of transformer architecture components, right? One thing I found personally in this year are the Kolmogorov-Arnold networks, a new type of neural networks that are very efficient for explainability reasons. It has mixed reviews, but this is personally, I think, one of the candidates. So now I want to talk about why do we even care about AI algorithms, right? Or algorithms in general. And if you look at fields other than AI, we also see similar trends. So in this graph, I want to show you how much performance boosts you can get by just optimizing on the algorithm side versus on the hardware side. So on the x-axis, you have again the year, and on the y-axis is some performance metric, right? Like how fast are you to solve a specific problem. And this graph is showing some benchmark, some standard computational problem where you run different algorithms. And you see from the 1940s to the 1970s, people for this specific problem, they've just been brute forcing solutions, and it's very inefficient. It's basically a constant, it's one, right? And then suddenly, for instance, the red curve, people been inventing for this specific problem like an algorithm called the Granitor, or the next one is Seamus and Cadan, and reached significant performance boosts in a short period of time. So you can see if pure brute forcing solutions has the efficiency order of 1, you suddenly get the efficiency order of 2 to the power of 40 just by using an algorithm, right? And you see this with different types of algorithms, which is the green curve and the blue curve. Just different approaches of various algorithms to solve the same set of problems, right? And then you also see what would happen if you just optimize on the hardware, which is the gray curve on the bottom right of this graph. You see okay, on the 1980s, you suddenly, people have been, for this specific problem, implementing faster and faster CPUs, and then you reach incremental performance boosts, right? Just by optimizing on the hardware side. But this is not enough to reach it will take many more decades to such that the hardware is good enough to even compete with the red curve, right? Which is just a simple, let's say, 10 lines of code of algorithm, probably, right? Rather than billions and billions of dollars of R&D, right? So we want, at the Innovation Game, we want to incentivize this kind of algorithmic breakthroughs rather than the current hardware-driven progress. And how do we do that, actually? Well, the answer lies in we're using blockchain technology. So who in this room does know what the proof of work mechanism is? Probably everyone heard of it, right? At some point of form, Bitcoin, etc. Now think of it as, or let's rephrase, the Innovation Game is basically a mechanism that uses the proof of work concept to select the best algorithms for a specific mathematical challenge. Or in another way, who in this room does know the traveling salesman problem? It's a very standard algorithm. So for people who doesn't know, let's say you have a map of 20 cities with the distances for each of the cities to each other, and you want to find the shortest path for this, for traveling amongst all the cities, right? So it is a typical problem that is used, for instance, for Google Maps, etc. And in order to solve this hard problem, you run different sets of algorithms, like people have different ideas. Maybe some algorithms are ultra fast to come to a solution, but the solution might not be the optimum solution. Some algorithms might be more slower, but they come with very accurate solutions to this problem, right? And so when people are coming up with all these different types of algorithm proposals, you can basically benchmark those algorithms and then find the most optimum algorithm and say this is the winner, right? And this benchmarking process, you can think of the proof of work mechanism, right? So you have a bunch of miners, which we call benchmarkers in our system, that are running these algorithms that innovators have put into our platform as like an IP value. And then the benchmarkers are selecting the most efficient algorithm just by solving these mathematical challenges that we have implemented into the platform, right? So on the right, you see like how the tick architecture works. So basically, on the left, we have the benchmarker, the miner, that is assessing the methods that the innovator on the right side is proposing to our system. And then we reward both of these parties with tokens, right? First, the benchmarker is because they're running the compute, and the second, the innovator is providing the IP, right? And then the token will then be sold or capture its valued to commercial enterprises, such that we can license the state-of-the-art algorithms, right? So at TIC, we created a system that we are able to capture IP value that was not possible before. So for instance, open source developing, people are posting something on GitHub, for instance, and then attach a license to it, for instance, the Apache 2 license, which says you're giving up, thank you for your commitments to the open source community, you're giving up all your IP, any derivative after your product that makes profit, you get nothing, right? But with our system, you can actually get compensated for doing open source work. Yeah, and one thing, maybe one minor detail as well, we need also verifiers that also check the solutions and the methods that are provided into the system are all valid, right? So that no one can like cheat the system. So basically, with this proof of work mechanism, we are incentivizing and rewarding open source development. And why is it still open source if you're having a commercial license, right? That's the question. It is open source because we are actually dual licensing the IP that is provided by the innovator. So one license is the open data license, which is commonly used for academics. That means when you use our algorithm, you can use it for free as long as you also publish the data that was used to process the algorithm, right? Which is a very standard thing in scientific literature. You're saying, when I publish a paper in biology and I will just post my results without providing a data set, people will be like, this is not scientific. We will not want to, this paper will not pass the peer review process, right? So we're really following that open source ethos of the scientific community by saying you can use our solution for free if you also publish the data, right? Or you can opt into another license, which is the for-profit license, where you would say, okay, you don't have to publish your data. You can just use our software as a service, right? And I think, for instance, someone like Google, for instance, wouldn't want to publish the whole data set just to use an algorithm that was implemented by us, right? They would rather say, okay, instead of publishing our whole user database, I just pay a license, for instance. So this is the smart way how we get away or come up with this ethos of staying open source while also protecting IP for each individual. And now the question is, okay, what defines a challenge that this whole system runs on? So one challenge I just mentioned as an example is the traveling salesman problem, right? But there are also others. In our platform, a challenge is a mathematical asymmetrical problem. So asymmetric means it is a hard computational problem to solve, but it is easy to verify, right? So that means it takes longer to compute a solution than it is to verify it, right? So I think in blockchain, everyone probably knows what this kind of problem could be. That's the ZK proving mechanism, right? So for ZK snarks, it takes some time to compute a proof, but it is a constant amount of time to verify it, right? So other areas in AI could be, it takes a long time to compute a machine learning training model, but it is very easy to verify it because you just run an inference step and see if the predictions or the weights are correct, right? There's also a lot of subtleties that we're currently working on. But also other fields in statistics or computational astrophysics, biology, chemistry, they use a lot of Bayesian inference. You can also, with Bayesian inference, you have basically an inverse problem. So what it means is, for instance, in physics, you want to simulate some kind of physical data set. Let's say you're simulating some universe data set, right? Given some input parameters, like the age of the universe, how much matter we have, how much hydrogen do we have in the universe, etc. And then once you created a data set, the astrophysicists are always asking themselves, okay, what were the initial parameters that created the data set, right? And this is also an asymmetric problem because it is easy to simulate a data set versus it's very hard to infer the original parameters. And yeah, these are the types of problems we want to include in our platform. But we also think of, if anyone is has a very smart idea about challenges that could be included to tick, please reach out. Especially we are interested, of course, in DeFi challenges. Like if you know like hard DeFi problems that require a lot of compute to solve, but easy to verify, just talk to us, please. And on the final note, I want to talk about something from a different perspective. So in the previous talk, we heard about this LLMs are we're using LLMs to do like all sorts of fun things because these models are fundamentally very, very powerful. And with this concentrating, let's say, capital and power of these big conglomerates that run and deploy these models, there's a certain point of centralization risks, because we found that the recent researchers by MIT, Anthropic, and DeepMind, they published a paper where you can use LLMs to actually innovate and find new algorithms that solve a specific certain type of problem, right? So why does it cause an issue? Why? Because, oh, I can just use an AI to find a solution to your problem, right? Isn't that wonderful? No, because then you're basically saying innovations or IP that a human person provides is suddenly a hardware-driven asset class. That means the more GPUs I buy, the higher the probability is that my LLM will find some algorithmic innovation through their models that they call function search in this specific instance. But this is very unfair because suddenly, as an open source developer, you're like, okay, there's no point in me looking for new algorithms because these guys, they can just buy more hardware and then outcompete me, right? And that's a worrying trend that we see at TIG. And I want to say we are the only protocol that can mitigate these effects because suddenly, if you use our platform as an open source developer, you get rewarded, right? You don't have it anywhere. So the options are either you let the big conglomerates take the lead and take all the rewards, and open source just vanishes because LLMs can do the job, or you say, I really want to support open source, and I want to be rewarded for it, and that's when you use TIG. So this is our final statement, basically. The innovation game combats centralization threats of AI-driven algorithm development through our open source reward system. Thank you.
Thank you, Kilian, for your expert insights on algorithmic innovation. And do we have any questions for Kilian? Please.
Hi, Kilian. I have a question. So when you said that there's a innovator, the benchmarkers, and a verifier, right? So how do we make sure that the benchmarker had the same hardware condition when they run the algorithms?
That there's a what?
I mean, like, how do we make sure the benchmarker have the same hardware condition at each moment when they run the algorithm to compare? Because because maybe I understand it's wrong, but for what I understanding, you mean the benchmarker mean just the miner, right? And
Yes.
the problem here, and the benchmarker we try to run maybe a different algorithm to see which one will be the winner, right?
Yes.
So what if the different benchmarker had different hardware condition?
Yeah.
So they're going to affect the result, right?
Yes. So your question is basically if someone has a lot of capital, has a lot of compute to provide, they will centralize all the tokens, and then the whole point will just vanish, right? I want to just quote you to the white paper. We have designed a reward system where we basically mitigate the centralization of hardware resources for our platform. But we can use like an analogy here that we used to design this mathematical driven reward system for this kind of hardware driven benchmarking. Imagine you have a rowing boat, right? And then a rowing boat, you have 10 people rowing to the race, to the finish line, right? And then suddenly you replace one of the rowers with like a super rower that has 100x times more power than all the other 9 rowers, right? But as an individual, this guy or this person or this girl will not be able to really outcompete or gain significant speed than another rowing boat that has a constant number of a higher average number of people that have strength, right? Because the single individual rower needs to be in sync with the other rowers, but if he's like putting in 100x of power, he necessarily doesn't gain 100x of speed for the whole rowing boat, right? Because we are punishing people that are providing more hardware resources in favor of people that have less hardware resources available.
How do we do that? I mean, like, how do we?
Oh, there's a mathematical formula for that in the white paper. I do not remember that from my head, but there's we call it the optimizable proof of work mechanism in our white paper.
Oh, I see. But the problem of the proof of work is we given the same problem, right? And everybody just run to see who go first, right?
Yeah.
But this is different, right?
So the problem instance is not always the same. We have a difficulty parameter. So some problems, so difficulty means number of dimensions, number of data points. So we can say, okay, someone with a lot more compute would probably tend to is incentivized to solve very hard problems because they might get more tokens out of it. Versus someone with less compute, he might choose to choose smaller problems, but smaller problems are not rewarded enough. Yeah, so there is this kind of balancing system in place.
Oh, I see.
Yeah.
Okay, thank you.
Okay, I think we can catch up later for more questions. We will still have some time for networking. So thanks once again, Kilian. And let me introduce our last speaker. And finally, we will share some insights and we will present you the Hero ecosystem. So Apta, Jerome already presented Apta. They are powering Hero AI search. So please welcome Gintautas, Chief Marketing Officer at Hero.io, and he will present our ecosystem briefly.
Hey guys. Yeah, so it's the last speech, so I will be quick on my speech. So basically, crypto promises are everywhere, but finding the real value usually is a gamble. So probably most of you are aware of these challenges in crypto. So there's a lot of data, and there is not a lot of good analytic tools to work with that data. Also, there's a complex barrier of entry for the new users because you have to integrate different wallets and different tools to just use simple tasks in Web3. Also, a lot of transparency issues and misinformation, especially by influencers, KOLs, and other actors in the space. And of course, there's a lot of scams and rug pulls, especially with the meme space currently. So yeah, that's why we created Hero, to combat these issues with data clarity and fraud protection, streamlined UX and direct engagement in our ecosystem, including our browser and other tools, credibility assessment, and privacy and security. So Shiram touched a lot of our agents during his speech, so I will not get into a lot of detail, but to briefly introduce each of these agents, so real-time sentiment analysis, so we can just ask what are people are talking about my coin on Telegram, what's the sentiment on Twitter, what's the sentiment in the news, and stuff like that. Influencer validator, so as Shiram presented, you can just simply find out what's the success rate of the coin, predictions of this influencer. Market researcher, so it's basically working around the data. Like Shiram mentioned, that you can ask which coins in certain category, in certain market cap reached certain price movements, such as all-time low, all-time high, and etc. Yeah, blockchain intelligence, so it's basically on-chain data integration. Security expert, so it's mostly focused on institutional investors, doing the diligence around the project, running background checks on teams, and similar things. And eventually we are moving to chat to trade functions. So as Shiram briefly touched, we will have these functions based on indicators. So for example, if real-time sentiment is positive on Bitcoin and the price reached 90K, sell 1 Bitcoin, buy Ethereum, and find the best APR staking farm to stake my Ethereum. Yeah, so this is the full Hero ecosystem. We have at the core is the Hero browser. So it integrates all these tools. So we have Hero Wallet, Hero AI search as presented. We are also integrating Hero ID. So Hero ID is, we are targeting this issue just not passing these QICs on every single platform. We want to integrate one QIC provider to tap into any other providers, and also do the liveness checks if the users are bots and etc. with the Hero ID. And we have Hero Pay, so it's a merchant services, so any shop, if they want to accept crypto, they can integrate Hero Pay. Yeah, so this is our target audience, retail investors and institutional investors. And our business model is pretty simple. We use premium subscriptions model, as well as Hero Ad network. So in Hero Ad network, we don't limit advertisers. It can be gambling, it can be any crypto project. Of course, we do the diligence before confirming them, not to be scams and etc. But we don't limit, like Google or other networks, the advertisers. Yeah, so this is the token utility at launch, how it ties out in our ecosystem. So it's pretty simple. We will have community incentives, yield farming at the start, and also we will have subscription fees and payments for ads, and we will use part of our revenue to do token buybacks. This is our tokenomics. We are not doing traditional sale with huge discounts to VCs. We are now focusing rather on retail, because our whole product is mostly focused on retail. So we are giving the power to the community. As you can see, over 70% of the tokens are dedicated to community through public sale and rewards, the community incentives. So if you want to catch up regarding tokenomics after the call, I'd be happy to discuss. And yeah, our team, Shiram introduced most of our AI team. We also have Web3 team. James just joined us as Hero Browser CEO. His background is in Brave and many other companies, such as Hotspot Shield. He was VP of Marketing at Brave. I personally was at CMO at Atlas VPN and other many companies. Brandon is from Verizon. He's our data lead, and Ada and Tadas worked closely with Animoca brands before. So yeah, what's next for Hero? So we are launching our browser at Q4 this year. Then we are pushing user acquisition to have a lot of users to test our product until March. And then we are launching our Hero token in 2025 March. So yeah, so that's it for my speech. And if you have any questions, feel free to come by. And this is the link to download our Hero browser to test it out. It's an early version, it's beta version, so would be happy with your feedback.
Thank you, Gintautas. So that's it for today. Thank you for coming to us. Now we are inviting you for a short coffee break and some networking. If you have any additional questions to Gintautas or our other speakers, please come to us and speak. And yeah, see you at future events. Have a nice week in Bangkok. Thank you.